Today we discuss on the first topic of derivative, which is derivative of composite function. Composite function वर डिस्कस करायच्या आधी आपण एक स्टेटमेंट थेरम पाहणार, which is also called as chain rule. The chain rule is if y is equals to f of u is a differentiable function of u and u is equals to g of x is a differentiable function of x, then y is equals to f of g of x is a differentiable function of x and dy by dx is equals to dy by du into du by dx. Again, if y is equals to f of u is a differentiable function of u and u is equals to g of x is a differentiable function of x, then y is equals to f of x is a differentiable function of x and dy by dx is equals to dy by du into du by dx. If we have to prove this theorem, first of all let us consider that del x tends to del x, del y and del u be a very small increment in x, y and u respectively, because y is equals to f of u is a differentiable function of u and u is equals to g of x is also differentiable function of x. If del x is a very small increment in x, del y is a very small increment in y, del u is a very small increment u, then as such that we can write this limit del u, del x tends to 0, del y tends to 0 and del u tends to 0. As u is a differentiable function, it is continuous, then we can write as del y upon del x is equals to del y by del u into del u by del x. If we take the limit, both sides of this equation, limit del x tends to 0 del y by del x is equals to limit del u tends to 0 del y by del u into limit del x tends to 0 del u by dx. We take at equation number first. Since y is a differentiable function of u, limit del u tends to 0 del y by del u and limit del x tends to 0 also del u by del x exists as u is a differentiable function of x, then we can write the limit del u tends to 0 del y upon del u is equals to del y by del u. We take equation number 2. Also limit del u tends to 0 del u by del x is equals to del u by del x. We also equation number 3 and limit del x tends to 0 del y by del x is equals to dy by dx. We take this equation number 4. This value of limit del u tends to 0 del y by del u, limit del x tends to 0 del u by del x and limit del x tends to 0 del y by del x, we put this value of equation 1. Therefore equation 1 become limit del x tends to 0 del y by del x is dy by du, limit del u tends to 0 del y by del u is dy by du into limit del x tends to 0 du by dx is du by dx. This rule also called as chain rule, hence proved. Today we start the derivative of composite function. Composite function means जर एखाद्या फंक्शनचा डेरिव्हेटिव्ह घ्यायचा आहे आणि फंक्शन ऑफ फंक्शनच्या फॉर्म मध्ये दिलेला आहे, अशा वेळेस एखाद्या फंक्शनला कंपोज करून आपण जर परत त्याला डिफरन्शिएट केलं तर कंपोजिट फंक्शनचा डेरिव्हेटिव्ह आपल्याला घेता येईल. फॉर एक्झाम्पल, if we know the derivative of x raised to the power n is equals to n into x raised to the power n minus 1. मी इथं जर n ची व्हॅल्यू चेंज केली, there is a lot of values of n, then again we can find derivative of this function. Then derivative of x raised to the power 2 is 2x, derivative of x cube is 3x square, again the derivative of x raised to the power 4 is equals to 4x cube up to and so on nth फॉर्म मध्ये आपण एक्स टू द पॉवर n चे डेरिव्हेटिव्ह फाइंड आउट करू शकतो. केव्हा? जेव्हा n ची व्हॅल्यू चेंज होईल. n ऑलरेडी नंबर ऑफ व्हॅल्यूज आहेत, बट जर x च्या ऐवजी x चं फंक्शन दिलं असेल, इट मीन्स दॅट फंक्शन ऑफ फंक्शन, तर आपल्याला डेरिव्हेटिव्ह फाइंड आउट करता येईल का? जर असं जर फंक्शन दिलेलं असेल तर त्या फंक्शनला काय म्हणता येईल? तेच फंक्शन मीन्स कंपोजिट फंक्शन. कंपोजिट फंक्शनचे स्टँडर्ड डेरिव्हेटिव्ह जर पाहिले, डेरिव्हेटिव्ह ऑफ स्टँडर्ड फंक्शन, डेरिव्हेटिव्ह ऑफ स्टँडर्ड कंपोजिट फंक्शन, फर्स्ट फॉर्म आपण तयार करू शकतो. डेरिव्हेटिव्ह ऑफ, इथं एक्स च्या ऐवजी जर फंक्शन रिप्लेस केलं, फंक्शन ऑफ फंक्शन मीन्स एफ ऑफ एक्स जर घेतला, तर डेरिव्हेटिव्ह ऑफ एफ ऑफ एक्स रेज टू द पॉवर n इज इक्वल्स टू n इंटू एफ ऑफ एक्स होल रेज टू द पॉवर n मायनस 1. We know that the rules of derivative d upon dx x raised to the power n is equals to n into x raised to the power n minus 1. x raised to the power n चा रूल्स आपल्याकडे होता. फंक्शन रेस्ट टू द पॉवर n आपल्याजवळ अवेलेबल नाही आहे, बट या फंक्शनला कंपोज करून x कन्सिडर केल्यानंतर एफ ऑफ एक्स डिफरन्शिएबल फंक्शन असल्यामुळे मी हा रूल्स अप्लाय करून एफ ऑफ एक्स रेज टू द पॉवर n चा डेरिव्हेटिव्ह घेऊ शकतो. परंतु घेतलेला डेरिव्हेटिव्ह हे कंपोज केलेलं फंक्शन आहे, त्यामुळे ज्याही फंक्शनला कंपोज केलं त्याचा आपल्याला परत डेरिव्हेटिव्ह घ्यावा लागेल. मीन्स डेरिव्हेटिव्ह ऑफ टेकिंग डेरिव्हेटिव्ह ऑफ एफ ऑफ एक्स अगेन. इट इज ऑल्सो कॉल्ड एज चेन रूल. चेन रूल मध्ये आपण पाहिलाय dy by du by dx is equals to again dy by dx. Secondly, we can write derivative of, तुमच्याजवळ अगेन डेरिव्हेटिव्ह माहिती असेल तुम्हाला, जर डेरिव्हेटिव्ह मध्ये पाहिला तर सेकंडली वी कॅन कॅल्क्युलेट द डेरिव्हेटिव्ह ऑफ अंडर रूट एक्स. व्हॉट इज द डेरिव्हेटिव्ह ऑफ रूट एक्स? रूट एक्स चा डेरिव्हेटिव्ह आहे 1/2 अंडर रूट एक्स. रूट एक्स चा डेरिव्हेटिव्ह आहे 1/2 रूट एक्स. जर इथं एक्स च्या ऐवजी एक्स चं फंक्शन दिलेलं असेल, x replaced by its function, then we can find the derivative of its standard composite function. Derivative of under root f of x is equals to 1/2 under root of fx. अंडर रूट मधल्या एफ ऑफ एक्स ला कंपोज करून रूट एक्स चा फॉर्म्युला अप्लाय केल्यामुळे आपल्याला परत एफ ऑफ एक्स चा डेरिव्हेटिव्ह घ्यावा लागेल, which is a standard form of derivative of under root of f of x. Same as we can find also the derivative of e to the power f of x. We know that the derivative of e to the power x is equals to e to the power x. Hence, we can write the derivative of e to the power f of x. आपल्याला f of x ला कंपोज करून x कन्सिडर करावं लागेल. e to the power x चा डेरिव्हेटिव्ह e to the power x च आहे, त्यामुळे e to the power f of x चा डेरिव्हेटिव्ह सुद्धा e to the power f of x च येईल. बट कंपोज केलेल्या फंक्शनचा मीन्स f of x चा परत डेरिव्हेटिव्ह घ्यावा लागेल, which is a standard form of the derivative of composite function. d upon dx of e to the power f of x is equals to e to the power f of x into again the derivative of f of x. Same as number 4th, derivative of a to the power x. We know that the derivative of a to the power x is equals to a to the power x into log of a. इथं ए टू द पॉवर एक्स चा डेरिव्हेटिव्ह ए टू द पॉवर एक्स इंटू लॉग ऑफ ए. इथं तुमच्याजवळ डेरिव्हेटिव्ह फाइंड आउट करायचा आहे. ए टू द पॉवर एक्स च्या ऐवजी एफ ऑफ एक्स दिलेला आहे, एक्स रिप्लेस बाय इट्स फंक्शन. देन वी कॅन राईट द डेरिव्हेटिव्ह ऑफ ए टू द पॉवर एफ ऑफ एक्स इज ए टू द पॉवर एफ ऑफ एक्स इंटू लॉग ऑफ ए. एफ ऑफ एक्स ला कंपोज करून एक्स कन्सिडर केल्यामुळे आपल्याला एफ ऑफ एक्स चा परत डेरिव्हेटिव्ह घ्यावा लागेल, विच इज अ स्टँडर्ड डेरिव्हेटिव्ह ऑफ ए टू द पॉवर एफ ऑफ एक्स. नेक्स्ट अगेन वी कॅन राईट सिमिलरली डेरिव्हेटिव्ह ऑफ 1 by f of x. We know that the derivative of 1 by x is equals to minus 1 upon x square. Hence we can write the derivative of composite function 1 upon fx is minus 1 upon f of x whole bracket square into again the derivative of f of x. Similarly, we can write the derivative of all trigonometric functions. Derivative of sine of f of x is equals to, we know that the derivative of sine x is cos x. We can write the derivative of sine of f of x is sine cos of f of x. And we take the again the derivative of f of x d upon dx of fx. Similarly, we can write the derivative of cos x. We know that the derivative of cos x is minus sine of f of x. We know that the derivative of cos x is equals to minus sine x. Hence, we can write the derivative of cos of f of x is minus sine of f of x into again a derivative of f of x. Similarly, we know the derivative of tan of x. The derivative of tan x is sec square x. Hence, we can write the derivative of tan of f of x is sec square f of x. F of x composed by x. Hence, we can write the again derivative of f of x. Next one, the derivative of tan of cot of f of x. We know that the derivative of cot x is equals to minus cosec square x. Hence, we can write the derivative of cot of f of x is minus cosec square of f of x, and we take the again the derivative of f of x. After that, the derivative of sec x, the derivative of sec of f of x. We know that the derivative of sec x is sec x into tan x. Hence, we can write the derivative of sec of f of x is sec of f of x into tan of f of x, and we take again the derivative of f of x. After that, the derivative of cosec of f of x. We know that the derivative of cosec x is equals to minus cosec x into cot x. Hence, we can write the derivative of cosec of f of x is minus cosec of f of x into cot of f of x, and we take the again the derivative of f of x, which is a required derivative of some standard composite function. Composite function किंवा कुठल्याही फंक्शनचा डेरिव्हेटिव्ह फाइंड आउट करायचा असेल तर डेरिव्हेटिव्हचे फॉर्म्युले आणि काही रूल्स आपल्याला माहिती असणं आवश्यक आहे. याच्या आधीच्या लेक्चरमध्ये आपण डेरिव्हेटिव्हचे सर्व फॉर्म्युलेज आणि काही रूल्स पाहिले होते. एका रूल्स मध्ये थोडीशी मिस्टेक होती आणि एक रूल्स त्याच्यामधून कट झाला होता, त्यामुळे डेरिव्हेटिव्ह रूल्स ऑफ डेरिव्हेटिव्ह मी परत घेतो. Then the rules of derivative means जर तुमच्याजवळ 2 or more than 2 means 2 किंवा 2 पेक्षा जास्त फंक्शन दिलेले असतील तर ते एकत्रित आल्यानंतर आपण त्याला डायरेक्टली डेरिव्हेटिव्ह घेणं पॉसिबल नसते, कारण आपल्याजवळ फॉर्म्युले जे आहेत हे काही स्पेसिफिक फंक्शनचेच दिलेले आहेत, काही स्पेशल फंक्शनचेच दिलेले आहेत. त्यामुळे आपल्याजवळ असलेल्या फंक्शनमध्ये कन्व्हर्ट करून आपल्याला त्याचा डेरिव्हेटिव्ह घेता आला पाहिजे. जर आपल्याला कुठल्याही फंक्शनचा डेरिव्हेटिव्ह घ्यायचा आहे तर आधी त्या फंक्शनला छोट्या छोट्या पार्टमध्ये डिस्ट्रीब्यूट करावा लागतो, त्याला डेरिव्हेटिव्ह म्हणतात. डेरिव्हेटिव्ह घेताना सर्वात महत्वाची गोष्ट एक लक्षात घ्यायची आहे की तुमच्याजवळ दिलेलं फंक्शन हे आपल्याला एक छोट्या छोट्या पार्टमध्ये डिस्ट्रीब्यूट करायचं आहे, नंतरच त्याला सॉल्व्ह करता येईल, कारण त्याचे फॉर्म्युले आपल्याजवळ छोट्या छोट्या पार्टमधलेच फॉर्म्युले अवेलेबल आहेत. जर आपल्याजवळ दोन किंवा दोन पेक्षा जास्त फंक्शन दिलेले असते, मी कन्सिडर करतो इफ यू अँड व्ही बी अ टू डिफरन्शिएबल फंक्शन then we can write it derivative of constant function into any differentiable function is equals to k into du upon dx. याचा सरळ मिनिंग आहे, कुठलंही कॉन्स्टंट फंक्शन जर तुमच्या फंक्शन मध्ये दिलेलं असेल तर तुम्ही कॉन्स्टंट फंक्शनला बाहेर घ्या, तुमच्याजवळ असलेल्या डिफरन्शिएबल फंक्शनचा डेरिव्हेटिव्ह तुम्ही इझिली फाइंड आउट करू शकता. सेकंडली, जर तुम्हाला दोन फंक्शन ऍडिशन किंवा सबट्रॅक्शनच्या फॉर्म मध्ये दिलेले असेल, दोन फंक्शनची ऍडिशन किंवा दोन फंक्शनची सबट्रॅक्शन दिलेली असेल तर तुम्ही त्याचा डायरेक्ट सेपरेट डेरिव्हेटिव्ह घेऊ शकता. कुठलेही दोन फंक्शन इन फॉर्म ऑफ एक्स मीन्स याला लिहिताना du अपॉन dx और प्लस मायनस dv अपॉन dx अशा प्रकारे लिहू शकतो. थर्डली, जर तुमच्याजवळ दिलेले दोन्ही फंक्शन प्रॉडक्ट फॉर्म मध्ये म्हणजेच मल्टिप्लिकेशन दिलेलं असेल, इट मीन्स दॅट द डेरिव्हेटिव्ह ऑफ u इंटू v या फॉर्म मध्ये दिलेले असतील तर तुम्ही याला लिहिताना u इंटू dv अपॉन dx प्लस v इंटू du अपॉन dx अशा प्रकारे लिहू शकता. नंबर फोर्थ, द डेरिव्हेटिव्ह ऑफ u अपॉन v इज इक्वल्स टू v इंटू du बाय dx मायनस u इंटू dv बाय dx अपॉन v स्क्वेअर. Now we have to find the derivative of different types of functions. The given question is differentiate the following function and function is y is equals to under root of x square plus 5. The given function is in composite form. You know that जर दिलेलं फंक्शन हे कंपोजिट फंक्शन असेल तर फंक्शन कुठल्या फॉर्म मध्ये आहे हे आधी शोधायचं आहे. जर दिलेल्या फंक्शनचा फॉर्म आपल्याजवळ अवेलेबल असेल आणि फॉर्म्युला कन्व्हर्ट करून आपण जर डिफरन्शिएट करत असू तर आधी तुम्हाला कुठल्या फंक्शनचा डेरिव्हेटिव्ह आपल्याजवळ अवेलेबल आहे ते शोधावं लागेल. द गिव्हन फंक्शन इज y इज इक्वल्स टू अंडर रूट ऑफ x स्क्वेअर प्लस 5. इट मीन्स दॅट द फॉर्म ऑफ गिव्हन फंक्शन इज अंडर रूट ऑफ fx. And we know that the derivative of root x is equals to 1 upon 2 root x. Hence, we can write the derivative of under root fx is derivative of under root fx is 1 upon 2 root of fx. Function is composite form. Hence, we can write again a derivative of fx. This we can apply in this form. Now differentiate given function with respect to x. X square plus 5 is in composition form. We take the derivative of y is dy by dx is equals to derivative of under root of x square plus 5. After differentiating under root of x square plus 5, we get 1 upon 2 under root of x square plus 5. By using the differentiation formula of derivative of under root of fx is 1 upon 2 root fx. And we take again derivative of fx, hence we can write here derivative of f of x. Here f of x is under root of x square plus 5, then we can write derivative of derivative of x square plus 5. The derivative of x square 1 upon 2 under root of x square plus 5. Derivative of x square is 2x and the derivative of 5, which is constant function, is 0. 2x plus 0 is 2x. 2x upon 2 under root of x square plus 5, 2 cancel, is equals to x upon under root of x square plus 5, which is the required derivative of y, dy upon dx. Example number second is y is equals to sine of log x. If we differentiate the given function with respect to x, then the derivative of y is dy upon dx, and the derivative of sine of log of x. दिलेलं फंक्शन ऑब्झर्व केलं तर आपल्याला इथं डेरिव्हेटिव्ह साइन एक्स चा आपल्याजवळ अवेलेबल आहे, अँड द डेरिव्हेटिव्ह ऑफ साइन एक्स इज कॉस एक्स. फंक्शन कंपोजिट फॉर्म असल्यामुळे इथं साइन ऑफ एफ एक्स दिलेला आहे, त्यामुळे डेरिव्हेटिव्ह ऑफ साइन ऑफ एफ एक्स इज इक्वल्स टू कॉस ऑफ एफ एक्स इंटू अगेन डेरिव्हेटिव्ह ऑफ एफ ऑफ एक्स. By applying this, we can write derivative of sine is cos log of x as it is, and we take again a derivative of log x. So cos of log x as it is, and the derivative of log x is 1 by x. Hence we can write it 1 upon x into cos of log of x, which is the required derivative of y, dy upon dx is equals to 1 upon x cos of log x. Next, example number 3 is y is equals to e raised to the power 10x. After differentiating with respect to x, we can write the derivative of y is dy upon dx is equals to derivative of e raised to the power 10x. E raised to the power 10x is in simple form. We have to find the derivative of e to the power x, and derivative of e to the power x is e to the power x. The derivative of standard composite form of e to the power f of x is e to the power f of x into again a derivative of f of x. By applying this formula, we can write it e to the power 10x into again a derivative of tan of x. And it is clear that we know the derivative of tan x, and the derivative of tan x is sec square x. Simply we can write it dy upon dx is equals to sec square x into e to the power 10x, which is a required derivative of y, dy upon dx is equals to sec square x into e to the power 10x. Fourth example, y is equals to log of x square plus 4. After differentiate with respect to x, the derivative of y is again dy by dx equals to derivative of log of x square plus 4. The given function is in the form of log x, and we know that derivative of log x is equals to 1 by x. After its composite form, we know that the derivative of log of f of x is equals to 1 upon fx into derivative of f of x. By applying this formula here, we can write 1 upon x square plus 4 into again a derivative of x square plus 4. By applying the rules of u plus v, we take a separate derivative of x square and the separate derivative of 4. Hence we can write it 1 upon x square plus 4 into the derivative of x square is 2x, and the derivative of 4, which is constant function, is 0. 2x plus 0 is 2x, and again 2x into 1 is 2x, is equals to 2x upon x square plus 4, which is a required derivative of y, is dy upon. Next example is y is equals to 5 raised to the power 3 cos x minus 2. If we differentiate the given function with respect to x, then the derivative of y is dy upon dx is equals to, again take the derivative of 5 raised to the power 3 cos x minus 2. This function is in the form of a to the power x, and the derivative of a to the power x is a to the power x into log of a. The composite function of a to the power x is derivative of a to the power f of x is equals to a to the power f of x into log a into again derivative of f of x. If we apply this formula, derivative of a to the power f of x, then we can write the derivative of 5 raised to the power 3 cos x minus 2 is 5 raised to the power 3 cos x minus 2 into log of 5. If the given function is composite form and 3 cos x minus 2 is considerable function, then we can take again derivative 3 cos x minus 2. This function 5 raised to the power 3 cos x minus 2 into log of 5, and the derivative of 3 cos x minus 2 is 3 is constant function. We take a separate derivative of cos x minus again derivative of 2 is equals to 5 raised to the power 3 cos x minus 2 into log of 5. 3 is constant, and the derivative of cos x is minus sin x, and derivative of 2, which is constant function, is 0. Therefore we can write it minus 3 sin x into log of 5 into 5 raised to the power 3 cos x minus 2, which is the required derivative of y, dy upon dx. Next example is y is equals to 3 upon 2x square minus 7 whole raised to the power 5. After differentiating with respect to x, we get the derivative of y, which is dy upon dx. 3 is constant. Again we take the derivative of 1 upon 2x square minus 7 whole raised to the power 5. This function we can write it also 3 into derivative of 2x square minus 7 whole raised to the power minus 5. Now the given function, which is in the form of function f of x, which raised to the power n, it means that given function is in the form of x raised to the power n, and the derivative of x raised to the power n is n into x raised to the power n minus 1. If the given function is in composite form, then the standard derivative of composite function whole raised to the power n is equals to n into f of x whole raised to the power n minus 1 into again the derivative of f of x. By applying this formula, we can write the derivative of 2x square minus 7 whole raised to the power minus 5 is n is minus 5 into 2x square minus 7 whole raised to the power minus 5 means n minus 1. After differentiating, if 2x square minus 7 is composite, then we take again a derivative of 2x square minus 7. We can write it 3 into minus 5 minus 15 into 2x square minus 7 whole raised to the power minus 6 into derivative of 2x square, 2 is constant function, and we take the derivative of x square separately, and again derivative of 7 minus 15 upon 2x square minus 7 whole raised to the power 6. X square, derivative of x square is 2x, 2x into 2 is 4x, and the derivative of 7, which is constant function, is 0. 4 into minus 15 is equals to minus 60x upon 2x square minus 7 whole raised to the power 6, which is a required derivative of y dy upon dx with respect to x, and the given function y is equals to under root of sin x square. If we differentiate the given function with respect to x, then we can write it dy upon dx is equals to derivative of under root of sin of x square. The given function, which is in the form of under root x, and we know that the derivative of root x is 1 upon 2 root x. If the given function is in composite form, then we can write again it derivative of under root fx is 1 upon 2 under root of fx into again a derivative of fx. By applying this formula, we can write it 1 upon 2 under root of sin of x square, and again a derivative of sin of x square. Now 1 upon 2 under root of sin of x square as it is. Next function sin of x square is in the form of sin x. If x square is a composite form, then we can take a derivative of sin x, and the derivative of sin x is cos of x square. X square is in a composite form, hence we take again a derivative of x square is equals to 1 upon 2 under root of sin of x square cos of x square as it is. The derivative of x square is 2x. Whole terms are in multiple form, hence 2 cancel. Then we can write x into cos of x square is x cos of x square upon under root of sin of x square, which is the required derivative of y dy upon dx. Next, example number 2 is y is equals to cot square x square. If we differentiate the given function with respect to x, then we can write it dy upon dx is equals to derivative of cot of x square whole bracket square. Now this function is in the form of f of x raised to the power n. Hence, we know the derivative of f of x whole raised to the power n is n into f of x whole raised to the power n minus 1 into again a derivative of f of x. By applying this formula, we can write it 2 into cot of x square into again a derivative of cot of x square is equals to 2 cot of x square into this function is in the form of cot x, and the derivative of cot x is minus cos x square x square. X square is in composite form, hence we take again a derivative of x square. Minus into 2 minus 2 cot of x square into cosec square x square into the derivative of x square is 2x. Hence finally we can write 2 into 2 4 minus 4x cot of x square into cosec square x square, which is a required derivative of y dy upon dx, and y is function cot square into x square. Next example, number 3 is y is equals to log of cos of x raised to the power 5. The given function is in the standard composite form log of f of x, and we know the derivative of log of f of x is 1 upon fx into derivative of fx. If the given bracket is composite form, then we can write it derivative of log of cos x is 1 upon cos of x raised to the power 5. After differentiating with respect to x, we can write the derivative of y is dy by dx is equals to d upon dx log of cos of x raised to the power 5. Derivative of log of fx is 1 upon fx. Hence we can write it 1 upon cos of x raised to the power 5. And the again derivative of fx means derivative of cos of x raised to the power 5. We can write 1 upon cos of x raised to the power 5 as it is. The derivative of cos is minus sin x raised to the power 5 as it is. Again we take derivative of x raised to the power 5 because x raised to the power 5 is in composite form. Now the derivative of x raised to the power 5 means 1 upon cos of x raised to the power 5 as it is, minus into 1 minus 1 sin of x raised to the power 5 as it is, into derivative of x raised to the power 5 is 5 x raised to the power 4. Hence minus 1 into 5 minus 5 x raised to the power 4 into sin of x raised to the power 5 upon cos of x raised to the power 5. We can write again it minus 5 x raised to the power 4 sin upon cos is tan of x raised to the power 5, which is a required derivative of y dy upon dx. In the example number 4, the given function is y is equals to x cube minus 2x minus 3 whole raised to the power 4 into x plus cos x whole bracket cube. Here x cube minus 2x minus 3 whole raised to the power 4 is one function, and x plus cos x whole bracket cube is another function. Let me consider that if the first function is u and second function is v, then we can apply the rules of derivative, which is u into v. You know about derivative of u into v is u into dv upon dx plus v into du upon dx. By applying this rule, we can write this function after differentiating with respect to x. The derivative of y is dy by dx is equals to the if u first function is u and second function is v. In this rule, u is first function, v is second function. First function into derivative of second function plus second function into derivative of first function. Similarly, we can write here first function u, it means that x cube minus 2x minus 3 whole raised to the power 5. Derivative of second function x plus cos x whole bracket cube. then plus, now second function v x plus cos x whole bracket cube into derivative of first function, and the first function is x cube minus 2x minus 3 whole bracket cube. Now we find the derivative of whole function simultaneously. Function which is before the d upon dx, write as it is, means x cube minus 2x minus 3 whole raised to the power 5. We take the derivative only x plus cos of x whole bracket cube. We know that the given function is in composite form, and this form is x raised to the power n, and the derivative of x raised to the power n is n into x raised to the power n minus 1. If the given function is f of x raised to the power n, then we can write again it derivative of f of x whole raised to the power n is n into derivative of n into f of x whole raised to the power n minus 1 into again a derivative of f of x. By applying this formula, we can write here 3 into x plus cos x whole bracket square 3 minus 2, 3 minus 1, 2 into again a derivative of x plus cos x. Now secondly, we can write here plus function, first function which is before d upon dx, x plus cos x as it is. The form of x cube minus 2x minus 3 whole raised to the power 4 is in x raised to the power n, and the derivative of f of x raised to the power n is n into f of x raised to the power n minus 1 into again derivative of fx. Now we can write here 4 into x cube minus 2x minus 3 whole raised to the power 4 minus 1 3, and we take again a derivative of bracket x cube minus 2x minus 3. First function x cube minus 2x minus 3 whole raised to the power 4 as it is into 3 into x plus cos x whole bracket square as it is into, by applying the derivative, first rule of u plus v, we can take a separate derivative of x and separate derivative of cos x. The derivative of x is 1 plus derivative of cos x is minus sin x, plus minus minus, we can write here 1 minus sin x plus x plus cos x whole bracket cube into 4 x cube minus 2x minus 3 whole bracket cube. By applying the rules of algebra, u plus v plus w, we can take a separate derivative of each function, and the derivative of x cube is 3x square minus 2 is constant, the derivative of x is 1 minus the derivative of 3 which is constant function is 0. Therefore, the derivative of y dy upon dx is 3 into x cube minus 2x minus 3 whole raised to the power 4 into x plus cos x raised to the power 2 into 1 minus sin x plus x 4 into this 4 x plus cos x whole raised to the power 3 into x cube minus 2x minus 3 into 3x square minus 2, which is a required derivative of y dy upon dx.